Hello everyone, myself Khadija Farah. I work in the backend department of Chakraborty and Lahkar Innovations Private Limited and would like to present to you the Julia programming tutorials. So let's get started. So I will be guiding you with some of the basics in Julia. So today we're going to see the introduction to Julia programming language. So before moving to what Julia programming language is, what it does, and how it is different from other programming language, we need to know few basic things about a programming language to explain and to give a proper introduction about Julia. So first we'll see what a static programming language and a dynamic programming language is. So, as you can see in the picture, a static programming language is okay. Suppose you have a variable, just like shown in the picture, you have a variable named name, and I am explicitly mentioning it as a data type of string. So, I'm giving string name, and I have initialized it to some value. So, name is equal to some name I'm giving in double quotes. So that's how you define a string variable. Now if I give the same variable name is equal to something else, some numerical value or something, that will show an error. That will show an error because we have explicitly mentioned that the name variable belongs to the type string, and now we cannot change its data type because it is as we give its data type, it is internally stored as a type of string. But when it comes to dynamic programming, we are just mentioning that we have a variable name and we're just mentioning that it is a variable. Now, when we give name is equal to something in double quotes, the compiler assumes that it is of type string and compiler assumes that variable to be of type string. Now, if I again change the name to some other integer value, compiler will read the value and understand that okay, it is of type integer, and then assumes that same variable to be as an integer variable. So every time when you give a different value, dynamically the compiler will keep reading the value and then assigning it to be of that data type. So this is what happens in a dynamic programming language, but the same won't happen in a static. In static, you can convert a variable to another type of data by conversion techniques, but just like how we've done in dynamic, we cannot do in static. So, and also for the same reason, because static programming language explicitly gives which type of data it is, so that the compiler won't take time to understand which data type it is, because we are explicitly giving the data type. So static programming languages are basically very fast and it has a very good performance. So Julia is a flexible dynamic language appropriate for scientific and numerical computing with performance compared to traditional statistical typed language. So Julia is basically a dynamic language, but it has the good performance and high speed like that of a static programming language. Now, we need to know one more thing, which is compiled and an interpreted language. So what is a compiled programming language and what is an interpreted programming language? So as you can see in the picture, you have a source code. So a source code is basically something which we write in the English language, the programming language which we learned in our own comfortable English language. But the computer doesn't understand this. Computer understand only zeros and ones. So we need a compiler which converts the source code to the machine code. So we use a compiler and it will be converted to the machine code which contains only zeros and ones. And this machine code will directly give you the result, whatever the result is. So this is what happens in a compiler, and a compiled programming language is typically very fast because it compiles the entire code all at once. And once it is entirely translated into machine code, reading machine code is very easy for the computer because computer understand only the machine code. So generally a compiled programming language is very fast and its speed is very high. But when it comes to an interpreter is like, suppose you are going to some other country and you are taking a person with you who knows the native language of that country. So it becomes very easy for you to communicate with all the others because you have this person. So whatever you want to ask to the common people of that country, you just ask this interpreter. Interpreter will directly give you the answer in that native language. Or if someone asks you something, the interpreter will directly translate to you and you will get the result directly. But the problem with interpreter is that it converts the entire code line by line. So it takes more time. So every time, so suppose your code has 1000 lines of code or 2000 lines of code, everything will be translated line by line, which takes more time. So which is not very efficient compared to a compiled programming language. So talking about Julia is a high level just-in-time compiled. Just-in-time compiled means compilation is done during the runtime and not before execution. So it's a high level just-in-time compiled dynamic programming language designed to give the speed of C++ while remaining everything is as easy as Python. So it gives the speed of Python, it gives the speed of static programming languages like C++ while itself being a dynamic programming language, and it is very easy to code and more easy to code than the programming language like Python. So thus making Julia very efficient, a high performance programming language and more easy to use. So talking about the other features of Julia, the core language imposes very little. Julia base and standard library are written in Julia itself, including primitive operations like integer, arithmetic and everything. So it means that you don't have to focus a lot about the semantics and rules of Julia because there are not a lot of its semantics and everything. And Julia has an extensive library of mathematical functions. So even though if you don't have any specialized knowledge about the scientific computing and everything, Julia has everything written in its standard library. So you just have to use making any user do comfortably all the scientific computations with ease. And also it calls the C functions directly without any wrappers or APIs. Julia, for example, the function toString like converting something to string, that is a C function, but in Julia you can use it directly. You don't have to use any wrappers or APIs for calling that C function. Then it has a built-in package manager PKG. So if you want to include any package in your Julia file, you just have to import the package manager PKG and then you can give that package's name. So yeah, it's very easy to include any package in your file. Then this thing I've already mentioned, it has an extensive library of mathematical functions with great numerical accuracy. And this also I've already mentioned that its performance is really good and approaching that of a statistically compiled languages like C. So in the next video, I will be explaining how to install Julia in your system, and some other basic things like, and how to use it in VS Code also. And then we'll be discussing about the basics of Julia, like how to use if statement, for, else, while loop, and all those things in Julia. So we'll see in the next video. Thank you.